Yeah, good evening. See, you studied final keyword yesterday. Final keyword. Final keyword. It is called as modifier. It is called as modifier because it modifies the behavior. Modifies the behavior of a variable, method, and class. It is called as modifier because it modifies the behavior of a variable, method, and class. Okay. It is used to prevent value of the variable, comma, method overriding, and inheritance. This is I given about variable. Variable part is completed. Method overriding, inheritance required. For example, what is method overriding? Same name, same parameter or different parameter? Different answers coming. Method overriding. Same name, same parameters. Method name same, parameter list is same. That is called method overriding. Method overriding. Can we override methods in the same class? Can we override? No, we cannot override. Inheritance required. Suppose I'll write inheritance class test. I given methods cannot be overridden in the same class because of ambiguity to call. Okay. See, suppose void show and no parameters. Here also void show, no parameters. Now this is overloading or overriding? Overriding. Once if you write a final, we cannot override. Okay. So actually it is called overriding. It is called method overriding, but we cannot override. Method overriding. Now we cannot perform because final method cannot be overridden. Note down. Error because final methods cannot be overridden. Error because final methods cannot be overridden. Error because final methods cannot be overridden. See, if you apply to variable, we cannot change the value. If you apply to method, we cannot override. Is it over? Say, before variable final if you write, before variable final if you write, the value of the variable cannot be changed. Okay. Before method, if you write final, that method we cannot override. We can prevent. Okay. Next, suppose, sorry, your extends also you have to write. Extends. If you don't write extends, it's a valid. Just extends also write it. See, it is test class, it is demo class extends test. Now, here if I write final, here if I write final, this is inheritance not possible. Here error. Here error comes. Error because final class cannot be inherited. That's it. Not on. Error because final class cannot be inherited. If you apply to variable, value cannot be changed. If you apply to method, method cannot be overridden. If you apply to a class, cannot be inherited. Error because final class cannot be inherited. Is it over? See, what is the purpose of final is you can prevent the value of the variable, you can prevent overriding, you can prevent inheritance. So your value, if you want to prevent, if you don't want to allow to change the value, then final. If you don't want to allow to change the method definition, then final. If you don't want to allow to inherit, if you don't want to allow to extend your class, then final. That is the purpose of final. That means at last all the places same, cannot be changed only. That is inheritance. What purpose? We'll modify, we'll add some, we'll do something. No, that's what we should not allow means final. Overriding what purpose? Same method if you want to redefine with another definition. That means modifying only. That is you can prevent. That is final. Next concept. This is about final. Next concept, access modifiers. Access modifiers. You studied variables. How many types of variables are there? 3 types. What are those? Instance variables, class variables, local variables. Instance variables, class variables, local variable. What is the scope of local variable? Limited to method only. Method only. Outside the method we cannot access. Studied no? Now, what is the scope of instance variable? That is life. As long as object is available, that variable is available. That is called life. Scope. Instance variable scope, block variable scope, limited to block only. Okay, method parameter scope, limited to method only. Instance variable, class variable scope, based on access modifiers, depends on access modifiers. That point I given. That is you are learning today. I didn't explain at the time. I given one point. Okay, I didn't given you see. I given life and scope. While giving a life and scope, I given that point. instance variables and class variable scope is based on access modifiers. That point I given. That is you are going to learn now. Okay. Now, so based on access modifiers. This point already covered. Okay. Now, access modifiers. See, in C++, in C language, we don't have access modifiers. C++, we have access modifiers. Like a private, protected, public, we have. Okay. Like in Java. Next, write it. First, access modifiers are also called access specifiers. Access modifiers are also called access specifiers because they specify access permissions. Access modifiers are also called access specifiers because they specify access permissions to variables, comma methods, comma classes, comma interfaces, dash dash, etc. Access modifiers are also called access specifiers because they specify access permissions to variables, methods, classes, interfaces, dash dash, etc. I'll explain. Next point, write it. There are 4 access modifiers in Java. First one, private. Second one, protected. Third one, public. I'll explain, just write it. There are 4 access modifiers in Java. First one, private. Second one, protected. Third one, public. Fourth one, I'll give. Before going to fourth one, see. For example, class A. Okay, class A. Here, integer A equal to 10. Private integer B equal to 20. Protected integer C equal to 30. Public integer D equal to 40. Now, like this, some other code. If I write like this, in C++, this is also considered as a private. That means by default private in C++ class. C++ structure by default public, but C++ class by default private. That means it is also private. It is also private if it is C++, but Java different. Now, in C++, 3 access modifiers are there. Why I am comparing C++ is better understanding. Okay. Say in C++ programming language, 3 access modifiers are there. Private, protected, public. 3 only. Which is default? Private is default. In class, which is default? In structure, public is default. Because in C++ structure concept also is there, but Java not there. Okay. So there are 3 access modifiers in C++: private, protected, public. Without writing access modifier, if you write, that is nothing but private, because by default is private. Now, here in Java, without writing access modifier, also one type of access modifier that is not a private, that is not a protected, that is not a public. What do you mean? So in C++, if you write like this, in C++, okay, now just give me answer. How many access modifiers are there in C++? 3. What are those? Private, protected, public. Now private, protected, public. Which is default? Private is default. Private is default. Clear no? Now that means if I write like this, it is private. If I write like this, protected. If I write like this, public. If I write like this in C++, that meaning private. Okay. But in Java, there are 4 access modifiers in Java. There are 4 access modifiers in Java. First one, private. Second one, protected. Third one, public. Fourth one. Now, without writing access modifier also, one type of access modifier. Okay. Suppose if I write default, default is a keyword. We cannot apply also another keyword that is. Okay. So which is default? Suppose if you write this is default. Suppose if I write here default, because already 2 members given answer, you observe default in online. Here what they given? Default. Okay. Now you observe. Suppose if I write default, which is default? Default is default. It will happen. It will be happen or not? So actually, without writing access modifier, also one type of access modifier, that is default. Little bit confusion is there. Okay. Suppose if I write default here directly. Suppose if I write default in this 4, which is default? Default is default. It will be happen. No? Got your mind? That is the reason I didn't write. That is the reason I didn't give until. Okay. So in C++ different, Java different. There are 4 access modifiers in Java. Without writing access modifier also, one type of access modifier, the type name not there. That is default. What do you mean? So instead of writing like that, what I am writing? No name. Which is default? No name is default. It is better, no? If I write directly default, default is default, it becomes. It will happen, no? So without writing access modifier also, one type of access modifier, the type name not there. That is default. Got it? Write this one. Private is not a default. Private in C++ that is. Java without writing also, without writing only default. Now I'll show you the difference also. In C++ private default. Without type only default. That's what I'm writing, no name. There is no name for that. That is default. That is default. See, in Java we have 4 access modifiers: private, protected, public, no name, which is default. No name is default. Okay. Now here, this is private variable, this is protected variable, this is public variable. This is, it is not a private, it is not a protected, it is not a public. It is one more type, but the type name not there. Not there. That is the reason I am writing no name. That is default. Okay. Now, what's the difference between these 4? All are instance variables only, no? All are instance variable. But instance variables, class variables, scope is based on access modifiers. Now, if your access modifier is applicable, then scope will be different. Now, all are instance variable, but scope is not same. It is different. The scope is different. This scope is different. Okay. That scope I'll explain. For understanding the scope, I'm writing some other classes. Okay. I'll write some other classes. Now, for understanding purpose, I'm writing one more class. What's the difference I have to explain? Now, private, protected, public, and no name. What's the difference? I would explain. That purpose, I'm writing one more class, class B inert A. Don't write this one, don't write, listen. One more class, C. Now, here, A class, B class, C class. 3 classes are written. A class, B class, C class. Between A class and B class, relationship is there. That is inheritance. Between A class and B class, relationship is there. That is inheritance. Between A class and C class, no relation. There is no relation. Okay. Now, for understanding the difference, I am writing one more class. Class E. Okay. Class E. It is one more class. This class inherits from A. Extends A. One more class also I am writing. Class D. Okay, D I'll write. Here E I'll write. It is D class. It is E class. Now, why these many classes? To understand the difference between 4 access modifiers. Okay. One more thing. For learning access modifiers, package concept required. Package. But till package not completed. For learning package, access modifiers required. Okay. Concept to concept relation is there. For learning access modifiers, package knowledge required. For learning package, access modifier knowledge required. Both at a time if you learn, one also will not get. That's what. First you concentrate on access modifier. Later package. Suppose these 3 under ABC package. Assume. Okay. These 2 under XYZ package. Assume. Okay. ABC is a one package which contain 3 classes. A class, B class, C class. XYZ is another class, another package which contains 2 classes, D class, E class. Okay. Now, why these many packages? Why these many classes? To understand the difference between these 4. Okay. Now, ABC package which contain 3 classes, A class, B class, C class. XYZ is another package which contain D class, E class. Between A class and B class relationship is there, inheritance. Between A class and D class also relationship is there, inheritance. But that is different, this is different still. How? This is inherited in the same package. This is inherited in another package. Difference is there, no? No. Between A class, C class, no relation. Between A class and E class, no relation. But these 2 classes also not same, different. This is in the same package is there. This is in another package is there. Okay. Now scope of the variables you observe. This variable scope. This variable scope. This variable scope is package scope. That means this variable within the package we can access. This variable without writing access modifier also one type of access modifier. That scope is within the package. So in the package you can access. Within the package mean this variable in how many classes it is visible? 3 classes. What are those? A class, B class and C class. 3 classes it is visible. In 2 classes it is hidden access. Okay. In 3 classes we can access in A class, B class and C class. This variable scope, private variable scope is within the class. Now that means only one class. Private variable scope is within the class. Outside the class we cannot access. That means this variable in how many classes we can access? Only one class. Which class? A class. That's it. Only one class. It is not visible to other classes. Okay. Protected variable scope. Protected variable scope is package scope and subclass scope. Even subclass can be outside the package also. So the scope is package scope and subclass scope. Subclass can be outside the package also. That means this variable, how many classes visible? According to package scope, how many classes? 3. According to subclass scope, how many classes? 2. B already written. So next one, D. So this variable within the package you can access. That means A class, B class, C class. Subclass also. Subclass can be outside the package also. That means in a B also, D also. B already written, D like this. Now this scope, public scope is not restricted. So there is no restriction for public. That means anywhere you can access. That means A, B class also, C class also, D class also, E class also. All classes you can access. No restrictions to access public. Okay. In previous all programs, we didn't write private. We didn't write protected. We didn't write public. That means which type? No name. Default. That is within the package you can access. That's what in C class also. Even relation is not there, we can access. In previous all programs, we written like without protected, without public. That is within the entire package you can access. That's what in other class also you can access in the same program. Okay. Now we have 4 access modifiers: private, protected, public, no name. No name scope is package scope. Within the package you can access. That means A class, B class, C class. Private variable scope is class scope. Within the class only we can access. That means only one class. Protected variable scope is package scope and subclass scope. Subclass can be outside the package also. That's what D class also we can access. Public, there is no restriction. Anywhere you can access. Scope is not restricted. Okay. Just write this one. Write this all. So subclass scope, package and subclass scope. Subclass can be outside the package also. Public scope not restricted. See, observe private, protected, public, no name. If you observe, that is also different. No? That is 3 classes. This is 1 class. This is 4 classes. This is 5 classes. Over. Is it over? See, I'll ask some questions. Give me answer. How many access modifiers are there in Java? 4. What are those? Private, protected, public, no name. Okay, without name. That which is default? No name is default. Okay, that is understanding purpose I given. If you give answer default also accepted. Default also accepted. Okay, understanding purpose I given. So without writing access modifier also one type of access modifier, that is type name not there. That is default. That is default because interface is there. In interface public is default. In interface, that is the reason. But in a class which is default means no name default. In an interface which is default means public default. Like that will be there. Without writing access modifier also one type of access modifier. That type name not there. That is default. So if you call it as no name also okay. If you call it as default also okay. If you call it as package scope access modifier also okay. They'll accept in interview because like that only is their concept. Like a package level access modifier. It is class level access modifier. Like that. It is package and subclass. This not restricted, no restriction. Okay. Now in these 4, which is more restrictive access modifier? Which is more restrictive? Private. Private is more restrictive access modifier. Now next, default. Default is next. Next, protected. It is very easy. It is 1 class, it is 3 classes, it is 4, it is 5. That order also can give 1, 3, 4, 5. So that is also required. Just you note down. Next, first private. After this, you can call it as no name. Otherwise, you can call it as default. Whatever you want, you can call. Or package scope access modifier also you can call. After this, protected. After this, public. Now, this is more restrictive to less restrictive. This order also important. Record further. More restrictive. It is less restrictive. So private is more restrictive. Public is less restrictive. Private actually no restrictions. Is it over? It is more restrictive, it is less restrictive. Order: private, default, protected, public. Private, default. Now, in one more point here, in Java, outer class cannot be private and cannot be protected. In Java, outer class cannot be private and cannot be protected. Outer class, inner class. If the class defined in another class, inner class. If the class is defined in another class, that is inner class. Whatever we are writing every day, those are outer classes. In Java, outer class cannot be private and cannot be protected. Suppose if I write class A, it is valid. If I write private class B, it is not valid. If I write protected class C, it is not valid. If I write public class D, it is valid. So it is valid. It is error in Java. It is error in Java. It is valid. In Java, you cannot apply private protected for outer classes. It's an error in Java. Okay, why it is error is, again, inheritance in C++ required to understand. C++ inheritance concept required to understand. Like, no, there's C++ also, you can understand. This private protected, not possible, remember, that's it. Because C++ inheritance, all inheritance types you have to remember. Then you can understand. Support private protected for outer classes. If you write, error comes. So it is valid, it is error, it is error, it is valid. Inner classes, again, 4 types of inner class are there. That is further comes. Same style, interface concept also is there. In Java, outer interface, interfaces further comes. Outer interface cannot be private and cannot be protected. Interface A. What is interface later? Now, private interface B. Protected interface C. Public interface D. If you write like this, it is valid, it is error, it is error, it is valid. Same. Interface is error, protected interface is error. What is interface later? Is it over? Now, this is about access modifiers. Okay. Next, relationships in Java. There are 2 relationships in Java. First one is a relationship. Second one has a relationship. First one is a relationship. Second one has a relationship. So what are the classes we are writing? Those are outer classes. What are the interface? Interface you didn't study. So whatever the classes we are writing, outer classes. Inner class means it's inside the class. If you write, that is inner class. Inner loop, outer loop, you studied, no? Like that only. Class in a class is called inner class. But inner class till I didn't explain. That later. Relationships in Java. There are two relationships in Java. First one is a relationship. Second one has a relationship. Relationships in Java is a relationship, has a relationship. Note down. Is a relationship refers inheritance, and has a relationship refers composition. I'll explain with programming. Is a relationship refers inheritance, has a relationship refers composition. So whatever you studied inheritance, that is called is a relationship. When we have to use is a, when we have to use has a, how to write is a, how to write has a, I'll show you. Is a relationship refers inheritance, has a relationship refers composition. Okay. See here, class A, otherwise class student. Okay, class student, integer. I given inheritance example at the time, like that only. Integer roll number. Okay, string name, string address. Okay, integer landline number. Like this I given. Okay, like integer roll number and student roll number, name, address, landline number. It's a one class. It's a one class. Okay. Here, what I'll do is say another class. Class student 2 extends student. Here, integer mobile number. Like string mail ID. I'll write mail ID. If I write like this. Now here, if I create student 2 object, memory allocated to student class also, student 2 class also. Okay. That means memory allocated for whole, like complete a student class, student 2 class. Okay. Otherwise, with first one small example, I'll show you. Then memory I'll explain. Class A, void show is one method. Suppose system.out.println something welcome. Say another class B extends A, public static void main. Now show method, instance method or class method? Show method is instance method or class method? Instance method. Okay. Show method is instance method. How do you know that is instance method? There is no static keyword. If static keyword is there, class method. Static keyword is not there, instance method. How many ways to access? What are those? Which class object required actually? A class. Now, can I create B class object? Can I call? Is it valid? B dot show. Is it valid? Yes. File. Okay, this class name file, save as something b.java. Now I'll compile Java C b.java, Java B. Welcome. Okay, like this you are getting. Now here, if I remove this extends A, is it valid? Is it valid? No. File, is it valid? It is not valid. Okay. See, compilation. We are getting error. Okay. It is not valid. See, show method is instance method. Compulsory object or object reference required. Which class required? A class required. Here I created B. It is not valid. But if I write like this, valid. Reason, there is a relationship. Now, if I remove this line, error. If I add this line, valid. Relation is there, allowed. Relation is not there, not allowed. Suppose, for example, one unknown person, he will come to your home. He wants to stay one day in your home. Will you allow? Will you allow? No. Suppose that person is either friend or relative. Will you allow? So relation is there, you are allowing. Relation is not there, you are not allowing. Here also, relation is there, it will allow. Relation is not there, it will not allow. This relation, we are calling like a easy relation. Why we are calling like that? See, actually which class object required? A class. Which class object I am using? Because B is a. Got it? Simple English only. Because B is a. So actually A class object required. A class object required. But I am using B. Because B is a. Because B is a. Simple English. Okay? That is the reason valid. This relationship is called easy relationship. Okay? So inheritance only we are calling like a easy. Easy inheritance, there is no change. Same. Write this example. In the above example, first write the program. B is a. In the above example, B is a. Say here which class object created? B class. B class object created. Okay. This object referred by small b. This object referred by small b. In this object, A members present, B members present. Show is a member of which class? A class. Main is a member of which class? B is a main is a member of B class. But how to differentiate which is A, which is B? That's what I am writing one more circle. It is A. Now give me answer. Here how many objects are there? One object only. Inner circle is not an object. Okay. One object only. In that object only two class members present. Two classes members present. So A members are present in B class, but A object we cannot see. Not there. A object is not there. A members present in B. Okay. A members present in B object, but A object is not there. There is no A object. Okay. Is it clear? This diagram also noted. Here how many classes are there? Two classes. How many objects? One object. In that object only two classes members present. So A class members are present in B object. Okay. There is no A class object. Is it over? See. Now, one more. Between A class and B class, any relationship is there? Between A class and B class, any relationship is there? No, we don't have. Okay, relationship. Now, integer x equal to 10. Integer x equal to 10. Now, this x which type of variable? Which type? Local variable. This x is a local variable. Okay. Now, here A something A equal to new A. I'm writing. Okay. What is this small a? Object reference. Object reference. Can I call variable? Is it primitive type variable or reference type variable? Reference type variable. Is it instance variable or class variable or local variable? What is? Local variable. Clear now? Now, it is local variable. It is local variable. This variable I'll write here. This is which type of variable? Now this variable I'll write here. Which type of variable? Instance variable. Okay. Now small a. Now small a is a reference of which class? Which class? A class. Small a is a reference of A class. You studied instance variable. Instance variable means a variable that is defined as a member of a class. That is called instance variable. A variable that is defined as a static member of a class. That is called class variable. Now, this A is a member of which class? Confusion started. 1 minute. This X is instance variable or class variable or local variable? Instance variable. Instance variable means member of a class. Which class? B class. It is instance variable or class variable or local variable? Instance variable means member of a class. Which member of which class? B class only. It is a reference of A class. It is a member of. You will get a confusion. That is the reason this variable I have taken. Actually, that variable not required for program. With this variable, you will get a clarity. Okay. So that is the reason only X I have taken. Actually, X is not required in my program. With this X only, you are understanding this one. Okay. X is a member of which class? B class. Small a is a member of which class? B class only. But it is a reference of which class? A class. Clear? Now, it is instance variable. It is also instance variable. It is a member of B class. It is also member of B class. Now, how many ways to access instance variable? What are those? Which class object required? Which class? B class. So B equal to new B. Now with this B dot X, can I call? Yes or no? With this B dot A, can I call? Yes. B dot A. With this A, can I call show? Yes or no? Show is a member of A class. Okay. Now you observe here. Here, for calling show method, which class object required? A class. A class object I created here. Okay. That reference is a member of which class? For calling this member, which class object required? B class object created. That is referred by B. With that B, I am calling A. With this A, I am calling show. Got it? Now your doubt is why we need to create like this? Why this much complicated? Okay, I'll explain. So now first of all, this relationship is called has a relationship. B has a A. B has a A. That is B is a A. Now it is B has a A. So write this program. In the above example, B has a A. B has a A. In the above example, B has a A. I'll get diagram also. First, write the program. In the above example, B has a A. I'll explain with the diagrams memory. First, is it over? Now I'll ask some questions, give me answer. In a class, what are the members are present? Members. Member nothing but variable method. Show is a one member present. That is show. In B class members, now not only main, A class reference. A class reference is also member. Main as well as A. Okay. See here B class object created. First B class object. Okay. B object. You observe here B object created. In the B object, B members present. This B object referred by small b. Okay. Now, here, what are the members present in B object? Small a as well as small a as well as main. Small a and main method. But small a refers A class object. So here one more object. This object has code here. It is A object. In this A object, what will be there? Show method will be there. So small a, this is, it is a reference of A class and it is a member of B class. Small a is a reference of A class and it is a member of B class. Now, here how many objects are present? Two objects are there. A object, we can see B object. Okay. A object reference is a member of B object. That's what B dot A. With this dot show. B dot A dot show. Write this diagram. It is of A class and it is a member of B class. It is a reference of A class and it is a member of B class. Now A members are present in A class only. A class reference is present in B class object. Okay, like that. B members are present in B object. Is it? See, this is relationship. Now, is a relationship, has a relationship, object diagrams you have seen. Now, in is a relationship, how many objects are there? One object. That is subclass object. Okay. Here we don't have superclass, subclass. It is no superclass, no subclass. We cannot call. Okay. Now, in a has a relationship, how many objects you have seen? Two objects. Is a relationship, one object. Has a relationship, two objects. Here now it is a or has a? Has a. It is has a relationship. A object also we can see. B object also we can see. But in is a relationship, only one object. That is B object. That is you have seen. Okay. But A members are present in B object. In is a relationship. Okay. Now, general question for understanding purpose. General question. Okay. Suppose apple and fruit. Apple and fruit. Relationship is there or not? Apple and fruit. Yes or no? Yes. Apple is a fruit or apple has a fruit? Is a fruit. Now, can we see apple? Yes or no? Can we see fruit? No. But fruit properties are present in apple. What do you mean? Fruit properties are present in apple. Apple is a fruit. Now, previous program, A class like a fruit, B class like a apple. Okay. Apple is a fruit. Fruit properties present in apple. But fruit we cannot see. Apple we can see. A class object we cannot see. B class object we can see. A class is not there. Object is not there. Fruit is not there. Apple is there. Okay. Got your point? Now, car and vehicle. Car is a vehicle or car has a vehicle? Car is a vehicle. Can we see vehicle? Can we see car? So vehicle properties present in car. Vehicle properties present in car. That's what car is a vehicle. Bike is a vehicle. Vehicle properties present in a car. Vehicle properties present in a bike also. Vehicle properties present in bus also. Now, computer is a vehicle. Is it right? No. Because vehicle property is not present. So between computer and vehicle, no relation. There is no relation. Okay. Now, car is a vehicle. Vehicle we cannot see, but car we can see. But vehicle properties are present in car. Got it? Now, car and wheel. Relation is there? Yes or no? Car is a wheel or car has a wheel? Car has a wheel. Okay. Now, car has four wheels. Like this, in a has a relationship, n number of you can create. One more time. Possible or not? One more time. Like this. Now, like this I created. 4 times I created. But here, will you write extends A, again extends A, will you write? No. That is one time only. So, one time required is A. Many times required has A. Like that, we have to select. Okay. That is with some other examples, I'll explain in tomorrow class. Okay. It is just only A class, B class I given. With some other examples, I'll explain tomorrow class. So, in a is a relationship, how many objects? One object. Has a relationship? Two objects will be present. Okay. But in is a relationship also, A class members present in B class. That means members are present. Members are present. Okay, like that. As a relationship, all we can see. N number of objects you can create like this. That is any number of you can create. One time required will go for is A. Multiple times required will go for has A. That is with other examples in tomorrow class I'll explain. Okay. We'll see continuation tomorrow. Class level access modifier. It is nothing but private. See, if you write private, this is we can access within the class only. This is class level access modifier. Within the class only we can access. Outside the class not possible. Now any other doubts? Online students? Just wait. Yeah, what is your doubt? See, class level access modifier, nothing but private. Real-time example for hazard relationship, tomorrow class. Access modifiers, definitely we use. We can protect our data means required. Hazard relationship, tomorrow also I'll explain. Tomorrow, not completed. Tomorrow also I'll explain. Any other doubts? Tomorrow I'll explain. Has a relationship not completed. Is a relationship, has a relationship, tomorrow class. Yeah, you can ask any query. Real-time example only, tomorrow class I'll explain. Devika, I'll explain tomorrow. Neha, what is your doubt? In array, we cannot store different data types, but in collection, we can store. Array list, we can store. Array, we cannot store. Array is similar data elements, but array list is collection. Homogeneous supported, heterogeneous supported. In array, we cannot store, but in array list, we can store. Yeah, I'll cover definitely. 30 plus collections I'll cover, not completed. Collections framework. I didn't cover till. Collections framework, separate topic is there. After exception handling, it will come. 30 collections I'll teach. 30 plus collections. Yeah, just oops also not completed till. Oops also not completed. See, just one principle, inheritance going on. Now we'll see continuation tomorrow.